Hola, chaps. Let's learn.
Hola, chaps. Mr. Turek here. This is for chemistry. Yesterday during our Google Meet, a question came up about the seashell activity. So I looked up the answer and want to share it with you now. What you do when you go online to look up the chemical formula for vinegar is you discover that it is called acetic acid. Now, if I were to share with you the Lewis dot structure for acetic acid, you would see it as CH3, then a bond to another carbon, double bond to an oxygen, single bond to an oxygen and hydrogen. So this part of it is acetate. It's a polyatomic ion that's listed on your list of common polyatomic ions. And think of all of this structure here, this acetate, as having a -1 charge, and this hydrogen as having a +1 charge. When you combine this with calcium carbonate, the calcium is a +2 charge. The carbonate is a -2 polyatomic ion. And you should write the chemical formula as being a double displacement reaction. This polyatomic ion trades places with this polyatomic ion. This positive cation trades places with that positive cation. Of course, you'll have to balance it knowing that this is a +2 charge, this is a +1 charge, this acetate is a -1 charge, this carbonate is a -2 charge, and write it accordingly from that. So really, on the seashell activity, there were two different chemical reactions that you were to puzzle out. So on question number 5, it was something like this one. And then question 6 or 7, it was, okay, so which one of the two products goes on to decompose into carbon dioxide and water? So think of it as two different chemical reactions. The first one being a double displacement, and the second one being a decomposition reaction. All right. So yesterday during our Google Meet, we picked some random problem and did it from beginning to end for this entire unit of stoichiometry. So many of you who missed yesterday's Google Meet, I'm going to do an example problem today, and this should end up our unit of stoichiometry. So starting from a word problem and going all the way through to calculating what the percent yield is for, here we go. I randomly found some problem, and in words it said this: copper 2 phosphate solid reacts with ammonium sulfate aqueous. So given just that much, please go ahead and pause this video to do it yourself. Predict what the products would be. Of course, first you have to write the words as a chemical formula correctly for each of the two reactants. Then predict the products. All right, take a moment and do it. I'm tired of pausing. I'm moving on. Okay, so copper 2 phosphate, I came up with this. Ammonium sulfate, I came up with this. And for predicting the products, I decided it was probably going to be a double displacement reaction. I have a positive and a negative, a positive and a negative. Certainly seems the way it's going to go. So this is what I predicted to be the products. Once you've gotten this far, the next step is to balance it, the rap sheet as I called it. And one thing I emphasized yesterday is that you don't have to go atom by atom. You can go polyatomic ion by polyatomic ion. So you could leave the phosphate as a PO4 as a single group, leave the sulfate SO4 as a single group as you build your rap sheet and balance the coefficients. Now, if you're like Nadine, you've probably already done it without even pausing. But for the rest of you, you might need to pause the video for a moment, balance the coefficients, and now I'm going to show you what I got. All right, I got coefficients of 1, 3, 3, 2. That's my balanced chemical equation. All right, And that's as far as you can take it with all the information I've given you. All I gave you was the word problem to start off with. Here are the two reactants. Please turn that into a formula, predict the products, write the equation, and balance it. Now we're going to move on, and I'm going to give you a new piece of information. Two pieces, actually. Now I'm going to tell you, oh, I'm going to start off by handing you 200 grams of the first reactant. That's a random number from student yesterday. And 120 grams of the second reactant, another random number from yesterday's Google Meet. Okay, so given those two quantities, the next step now is to identify for me which one of the two reactants is the limiting reactant. All right, again, pause the tape, figure it out. Now I'm going to move on. Okay, so to figure out which one is the limiting reactant, I can't just look at it and say, well, clearly it's 120 grams because that's the smaller quantity. No, 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 no. I have to look at how many moles of each of the two I actually have and ratio that to the number of moles that I want for a balanced chemical reaction. Remember, I want 3 moles of the second reactant for every 1 mole of the first reactant that I generate. And I see the lighting's not quite so good for you, but all right. Yeah, best I could do. So your current task is to identify the limiting reactant. And I'm now going to reveal the answer. I have to calculate the molar mass of the copper 2 phosphate, and I got 380.6 grams per mole. For the ammonium sulfate, I get a molar mass of 132.1 grams per mole. How did I do that? I went to the periodic table. I looked up the mass of each atom that went into the total. In this case, 3 times the mass of 1 copper, 2 times the mass of the phosphate group. The phosphate group is 1 phosphorus and the mass of 4 oxygens added together. So you have to double that group, add that to 3 times the copper, and I got 380.6 grams per mole. So now I can take the two given quantities, 120 grams of this, ratio that to 380.6 grams per mole, 120 grams of that, ratio it to 132 grams per mole. Okay, but one last little step, right? So first of all, I'm calculating I have 0.525 moles of the first reactant, and I have a measly stinking 0.908 moles of the second reactant. I now have enough information to determine which one of these is the limiting reactant. It's not necessarily the smaller of these two numbers. It's the smaller of the two ratios based on how many I want of each. I want 1 mole of this first reactant for every 3 moles of the second reactant. So the ratio that I'm looking at is 0.525 moles to 1 compared to 0.908 to 3, since I need 3 moles of the second reactant for every 1 mole of the first reactant. And the ratio of the first reactant is I have a little over half of what I need, whereas the ratio for the second reactant is less than 1/3 of what I need for that balanced chemical reaction. So of the two, I'm going to run out of the second reactant first, and therefore, these 3 dots is the mass symbol meaning therefore, the ammonium sulfate is the limiting reactant. But wait, there's more. We're finishing off stoichiometry unit, and we're not merely starting from a word problem, predicting the products, writing the balanced equation, and then if I give you more data and say, oh, I got so many grams of this, so many grams of that, identify which one's the limiting factor. Now, the last 2 steps are predict what is the theoretical yield for the products. And what I've done is I've calculated the theoretical yield for the first product of copper sulfate. So go ahead and take that step on your own right now and calculate Given that I now know that the ammonium sulfate is the limiting reactant, calculate how many moles and then how many grams of copper sulfate will I produce under these conditions. Okay, so I have an excess amount of the first reactant. I need to do my calculation based on the limiting reactant because this is what I'm going to run out of first. All right, and switching to the answers. Here we go. So your current task is calculate the theoretical yield for the copper sulfate. And I'm hoping that the lighting looks adequate for you. Doesn't really look adequate to me. Let's try that. Back to there. All right, so I have to go by the balanced coefficients of my chemical reaction. I actually have 0.908 moles of the limiting reactant. For every 3 moles of that, I produce 3 moles of the copper sulfate, copper 2 sulfate. Therefore, the ratio is just 1, 3 to 3. And that means I have 0.908 moles of copper sulfate produced. Next, I look up the mass of copper, the mass of sulfur, the mass of 4 oxygens, add them together, and that gives me the molar mass of copper sulfate. I get 159.6 grams per mole. Last step. If I actually produce 0.908 moles of this stuff, and 1 mole of it is 159.6 grams, how many grams do I theoretically produce? You multiply those two numbers, and the theoretical yield works out to be 144.9 grams. Okay, so that's my calculated theoretical yield. Now there's one last step in this entire stoichiometry unit, and that step is to go in the lab, do the actual reaction, carry out this experiment, take the product, and measure how much of it did you actually produce? How much of it did you really end up with? Maybe some of it got spilled on the floor, left in the container, stuck on the filter paper, whatever happened. Let's say that you measure that you only got 135 grams of this first product, copper sulfate. The percent yield is the ratio of what you actually measure to what you theoretically expected to get as a percentage. So, finishing it off, the percent yield is the actual measurement divided by the theoretical expectation times 100%. What do you get? All right, well, I'm not waiting. In this situation, I get 135 over 144.9 grams, units canceled, times 100%. It's 93.2%. Usually, you can't measure it to a tenth of a percent. So 93% is what I somewhat expect in real life. And that's a really decent type of result. All right, so this is the end of the stoichiometry unit. In this video segment, I first helped you with a question that was posed about the seashell activity, and now I've worked a stoichiometry problem from the very beginning, starting with just words, to the very end that says, oh, when I did it for real, I ended up with this percent yield. I would love to be able to assess you somehow on an end-to-end stoichiometry problem of this nature. Not sure how I might do that, but I would certainly enjoy doing this as a test on you. All right, ciao for now.